It was the summer of 2025. Astronomers were doing what they do every night. They were watching the sky. Cameras and telescopes across the world were scanning space, looking for anything new. Most nights, nothing unusual happens. But on July 1st, 2025, something did. A telescope system called ATLAS, short for Asteroid Terrestrial Impact Last Alert System, picked up a strange signal. It was a small dot of light. At first, it looked like nothing special, just another rock floating through space. But when scientists studied its path more closely, they noticed something odd. This object was moving fast, very fast. Normal comets and asteroids in our solar system move in curved paths. They orbit the sun again and again, following the same route for thousands of years. But this new object was different. Its path was not curved like a circle. It was almost a straight line, cutting through the solar system like an arrow. Scientists have a name for this kind of path. They call it hyperbolic. And when an object moves in a hyperbolic path, it usually means one thing. It does not belong to our solar system. It came from somewhere else, from deep, dark space, far beyond anything humans have ever visited. This made astronomers very excited. They gave the object a name, 3I Atlas. The number 3 meant something important. This was only the third time in human history that scientists had confirmed an object from outside our solar system passing through it. The first one came in 2017. It was called Oumuamua, a Hawaiian word meaning scout or messenger from afar. That object had a strange, flat shape, unlike any comet or asteroid ever seen before. Some scientists even wondered quietly at first if it could be something built, something artificial. In the end, no proof was found, and most experts agreed it was likely a natural object. But the mystery stayed in people's minds for years. The second interstellar visitor came in 2019. It was called Comet Borisov. It behaved more like a normal comet, and scientists were able to study it and explain most of its features. The excitement from Borisov calmed the debate for a while. Now, in 2025, came the third visitor. And this time, scientists were ready. They had better telescopes. They had learned lessons from the first two visitors. They knew this chance would not last forever, because interstellar objects do not stay in our solar system. They pass through quickly and disappear again into deep space, never to return. So, teams of astronomers around the world rushed to point their instruments at 3I Atlas before it moved too far away. As days passed, more data came in. Scientists worked out that this object was some kind of comet. Comets are usually made of ice, dust, and frozen gases. When they get close to a star, the heat causes the ice to turn into gas. This creates a glowing cloud around the comet, called a coma. Sometimes it also creates a long, bright tail. As 3I Atlas moved closer to the sun, this is exactly what began to happen. Its icy shell started to warm up. A cloud slowly formed around it. For scientists, this was excellent news. A glowing coma is like a fingerprint. By studying the light coming from it, researchers can learn what a comet is made of without ever touching it. But there was a problem. As the comet moved closer to the sun, it also moved closer to Earth's line of sight to our star. This meant that for a period of time, the sun's brightness would block ground telescopes from getting a clear view. Scientists knew they were racing against time. This is when NASA turned to one of its most powerful tools, the James Webb Space Telescope. Unlike telescopes on the ground, Webb sits far out in space, away from Earth's atmosphere. It can see details that no ground telescope can match. It is especially good at picking up infrared light, and a type of light invisible to human eyes, but full of information about temperature and chemistry. In August 2025, Webb turned its powerful eye toward 3I Atlas. Scientists around the world waited eagerly for the results. What came back left many of them stunned. The chemical signature of 3I Atlas was unlike anything astronomers had measured before. It contained water, which was expected. It contained carbon dioxide, also expected. But it also showed high amounts of methane and something else that caught scientists' attention immediately, unusually high levels of a rare form of hydrogen called deuterium. Deuterium is sometimes called heavy hydrogen. It exists in small amounts almost everywhere in the universe, including in comets from our own solar system. But the amount found in 3I Atlas was far higher than normal. In fact, it was among the highest levels ever recorded in any comet from anywhere. This single detail told scientists something remarkable. High deuterium levels usually form only in extremely cold environments, places where temperatures drop far below anything found near our sun. This meant that 3I Atlas likely formed in a freezing, distant part of the galaxy, long before our own solar system existed. Some researchers estimated that this ancient traveler could be over 10 billion years old. Think about that for a moment. 10 billion years. Our sun is only about 4.5 billion years old. This meant 3I Atlas could be more than twice the age of our own star. It may have formed when the Milky Way galaxy itself looked completely different from how it looks today. For scientists, this was thrilling news. It was like holding a piece of the ancient universe in their hands, a frozen time capsule that had traveled for billions of years before finally passing close enough for humans to study it. But the excitement did not stop there. As Webb continued watching, astronomers noticed something else, something they did not expect. Deep within the glowing coma, tiny patterns of light and gas seemed to shift in unusual ways. Small jets of material appeared to move, not in the smooth, predictable pattern typical of an ordinary comet, but in a rhythm that some researchers struggled to explain right away. At first, most scientists assumed this was simply normal comet behavior. Comets often release gas unevenly as different parts of their icy surface warm up at different times. This can create jets, sprays, and shifting shapes within the coma. It had been seen before on other comets, many times, but a few researchers were not so quick to dismiss it. They pointed out that the patterns from 3I Atlas looked different, more structured. Almost as if something inside was responding, not just reacting randomly to heat, but reacting in a way that seemed almost deliberate, almost alive. Of course, no one had proof of that, not yet. Most experts urged patience and caution, reminding the public that unusual does not mean impossible to explain with normal science. Ancient comets, especially ones formed under strange, extreme conditions billions of years ago, can behave in ways scientists have simply never observed before. Still, the questions lingered. Why did the patterns look so different? Why did an object so old, from such a distant and mysterious past, choose this exact moment to reveal such strange behavior, right as humanity's most powerful telescope happened to be watching? As 3I Atlas continued its journey through the solar system, scientists knew one thing for certain. This was not an ordinary comet. And whatever the true explanation turned out to be, the answer was still hiding somewhere in the data, waiting to be found. The next round of observations would bring answers that many did not expect. After the first wave of data from the James Webb Space Telescope, scientists did not stop watching. If anything, they watched more closely than ever. 3I Atlas was moving fast, and every week that passed brought it closer to the sun and closer to disappearing from view forever. Researchers around the world knew they had a short window of time to learn everything they could. So, teams began comparing new data with the old. They wanted to know if the strange patterns seen earlier were just a one-time glitch, or if they were something real, something repeating. The answer came back clear. The patterns were real. As 3I Atlas moved through space, its icy shell kept reacting to the sun's heat. Jets of gas continued shooting out from its surface, forming the glowing coma around it. This part was expected. Comets have behaved this way for as long as humans have studied them. But the timing of these jets was what puzzled scientists the most. On a normal comet, gas jets usually follow a simple pattern. They grow stronger when a comet gets closer to the sun and weaker when it moves farther away. It is mostly driven by heat, nothing more complicated than that. But 3I Atlas was not following this simple rule. Instead, its jets seemed to pulse. They would grow strong, then fade, then grow strong again, almost like a heartbeat. Researchers ran the numbers again and again, checking for mistakes in their instruments, but the pattern held steady across multiple observations, from different telescopes, on different days. This was unusual, very unusual. Some scientists suggested a possible explanation. Perhaps the comet's nucleus, the solid core hidden deep inside all that gas and dust, was spinning. If the nucleus was rotating, then only certain parts of its surface would face the sun at different times. This could create a pattern where gas escapes more strongly in bursts, matching the object's rotation speed. It was a reasonable idea. Many comets in our own solar system show similar rotation-driven patterns. But when researchers tried to match the timing of 3I Atlas's pulses to a steady rotation speed, the numbers did not fit perfectly. The pulses seemed to shift slightly over time, speeding up in some periods and slowing down in others. A spinning nucleus should keep a fairly steady rhythm. This one did not. This small detail was enough to keep the debate alive. On one side stood scientists confident that better data would eventually explain everything through normal physics. On the other side stood a smaller group of researchers who believed something more complex might be happening inside 3I Atlas. They did not claim to know what that something was. They simply were not ready to rule anything out. As the debate grew louder online, another discovery added fuel to the fire. Scientists studying the chemical makeup of the coma noticed something they had not expected. Alongside water, carbon dioxide, and methane, they detected small traces of complex organic molecules. These are carbon-based molecules, the same basic building blocks found in living things here on Earth. To be clear, organic molecules are not the same as life. They are commonly found on comets, asteroids, and even in giant clouds of gas deep in space. Their presence does not mean anything is alive. Many ordinary space rocks contain similar molecules formed through simple chemical reactions over millions or billions of years. But finding them on an object as old and unusual as 3I Atlas added another layer to the mystery. Combined with the record-high deuterium levels, the unexplained gas pulses, and the ancient age of the object, some researchers began to wonder aloud, what kind of environment could create an object like this? News outlets picked up the story quickly. Headlines appeared across the internet, some careful and scientific, others far more dramatic. Social media exploded with theories. Some people online joked that 3I Atlas might be a giant ship powered by hidden engines, deliberately slowing down and speeding up as it studied our solar system. Others compared it to Oumuamua, the mysterious first interstellar visitor from 2017, insisting that history was repeating itself. Serious scientists tried to calm the noise. Leading astronomers reminded the public again and again that no confirmed evidence of anything artificial or alive had been found. The pulses in the gas jets, they explained, were likely caused by a complex, uneven surface on the comet's nucleus. Some parts of the surface might be covered in different materials, some more reactive to sunlight than others. This alone could explain irregular timing without needing any exotic explanation. Still, even these careful scientists admitted one thing publicly: they had never seen a comet behave quite like this before. The object simply did not match any of the patterns collected from thousands of comets studied within our own solar system. This admission, small as it was, spread far and wide. When trusted scientists say the words, "We have never seen this before," people listen closely. And in the age of the internet, those words can travel faster than any explanation meant to calm them down. Meanwhile, more telescopes joined the effort to study 3I Atlas. Hubble captured new images. Spacecraft already exploring other parts of the solar system, such as Lucy and Psyche, turned their instruments toward the object during rare windows of opportunity. Even smaller observatories positioned to study infrared light added pieces to the growing puzzle. Each new dataset gave scientists more detail, but not necessarily more certainty. If anything, the mystery grew larger the more they learned. The comet's chemistry was ancient and strange. Its behavior did not match known models, and its true origin, somewhere far beyond our solar system, remained completely unknown. Researchers began openly discussing new theories, careful to separate solid evidence from speculation. Some proposed that 3I Atlas might have formed near a very different kind of star than our Sun, perhaps one that no longer exists today, having burned out long ago. Others suggested it might have passed close to multiple star systems during its long journey through the galaxy, picking up unusual material along the way, layer by layer, over billions of years. None of these theories claimed the object was alive. But none of them fully explained the strange rhythmic gas pulses either. As 3I Atlas continued its silent journey through the solar system, unaware of the debate it had caused on a small blue planet nearby, scientists faced a difficult truth. They were watching an ancient traveler unlike anything humanity had ever studied, and every new answer seemed to create two new questions. Time was running out. Soon, the object would move too far from the Sun and too far from Earth for even the most powerful telescopes to gather any more detailed information. Whatever secrets 3I Atlas was hiding, scientists knew they had only a limited window left to find them, and that pressure was about to lead to one of the most debated moments in the entire story. By early autumn of 2025, 3I Atlas was no longer just a topic for scientists. It had become a worldwide conversation. News channels ran segments about it. Podcasts debated it for hours. Millions of people who had never cared about comets before were suddenly watching every update closely. At the center of it all sat one simple, unanswered question. What was really happening inside this ancient traveler? Scientists split into two general camps. This did not mean they were enemies. Most of them respected each other's work deeply. But they disagreed on how to interpret the strange data coming from 3I Atlas. The first camp, and by far the larger one, urged calm. These researchers pointed out that space is full of surprises. Just because something behaves in a way scientists have never seen before does not mean it is unnatural. It simply means humanity has not studied enough objects like it yet. This was, after all, only the third confirmed interstellar visitor ever observed. With such a small sample, of course, strange details would appear. There was nothing yet to compare it against. These scientists reminded the public that comets in our own solar system still surprise researchers sometimes, even after decades of study. An ancient comet, formed under conditions billions of years old in a completely different part of the galaxy, could easily behave in ways that simply do not match anything nearby. Unusual chemistry, they explained, was expected from an object this old and this rare. The uneven gas jets, they said, most likely came from a lumpy, uneven surface, something like a rocky landscape covered in patches of different material, each reacting differently as sunlight moved across it. To this larger group, mystery did not mean anything more dramatic than that. An ancient, unfamiliar object slowly revealing its secrets, piece by piece, as better instruments studied it. The second camp was much smaller but louder online. These researchers agreed that no proof of anything artificial or alive had been found. They were careful to say this clearly every time they spoke, but they also believed the data deserved deeper investigation before jumping to comfortable conclusions. They pointed to 3 details that together felt unusual enough to keep asking questions. First, the record-high deuterium levels, higher than anything ever measured in a comet before. Second, the shifting pulse-like rhythm of the gas jets, a pattern that did not match a simple, steady rotation. Third, the presence of complex organic molecules, the same basic chemical building blocks found in living things, although common enough in space to not be proof of anything by themselves. None of these 3 details on their own meant much. But together, some researchers argued, they created a pattern strange enough to deserve very careful, very patient study, rather than a quick explanation. This careful, cautious stance was often twisted once it reached social media. Headlines dropped the careful language and jumped straight to dramatic claims. Video titles suggested secret messages hidden in the data. Online forums filled with theories about hidden structures inside the comet's core, invisible to current instruments. Some claimed that world governments already knew the truth and were hiding it from the public. Serious astronomers watched this spread with growing frustration. Many gave interviews specifically to correct the record, explaining patiently again and again that speculation was not evidence. A shifting gas pattern was not proof of intelligence. Organic molecules were not proof of life. The story, they said, was fascinating enough without adding false claims on top of it. Still, the public fascination did not fade. If anything, it grew stronger with every passing week. Part of this fascination came from history. This was not the first time an interstellar visitor had sparked wild theories. Back in 2017, Oumuamua caused a very similar reaction. Its strange, flattened shape and unusual acceleration as it left the solar system led some scientists to seriously study whether it could be artificial. In the end, most researchers concluded it was very likely a natural object, perhaps a fragment of ice pushed along by escaping gas, too faint to detect directly. But the debate around Oumuamua was never fully closed in the public imagination. Some questions remained technically unanswered, simply because the object moved too fast and too far away before enough data could be collected. Now, with 3i Atlas, many people felt like history was repeating itself. Except this time, humanity had better tools. The James Webb Space Telescope was far more powerful than anything available in 2017. Surely, people hoped this time scientists would get a clear answer, one way or another, before the object disappeared again into deep space. That hope pushed research teams to work faster. Observation schedules were rearranged. Extra telescope time was requested from observatories around the world. Every available instrument capable of studying comets was pointed toward 3i Atlas whenever possible, racing against the object's steady path away from the sun. New data began arriving almost daily. Most of it confirmed what scientists already suspected. An ancient, chemically unusual comet, behaving in ways not yet fully understood, but still very likely explainable through natural processes. But a few pieces of new information reopened the debate all over again. One dataset showed that the timing of the gas pulses appeared to sync, at least loosely, with the object's position relative to the sun in a way slightly different from a simple rotation model. It was a subtle detail, easy to miss buried deep within pages of technical data. But the small group of cautious researchers noticed it immediately and raised new questions in scientific papers, carefully worded, avoiding dramatic claims, but clearly asking for further investigation. Mainstream scientists responded quickly, offering updated models that could still explain the pattern through natural surface features, just slightly more complex ones than first assumed. The explanation made sense to most experts, but it did not fully satisfy everyone. And so the debate continued, quietly, professionally, mostly within scientific papers and conferences, even as the public conversation online grew louder and less careful with every passing day. Through it all, one truth remained unchanged. No confirmed evidence of life, intelligence, or anything artificial had been found inside 3i Atlas. Every strange detail still had a possible natural explanation, even if that explanation required an object more unusual than anything studied before. But as 3i Atlas continued its journey away from the sun, heading back out toward the emptiness of interstellar space, scientists knew their time to study it was almost gone. Whatever answers still remained hidden in its ancient ice and gas would need to be found soon, or lost forever, as the object faded permanently beyond the reach of even the most powerful telescopes on Earth. The final push to understand this ancient traveler was about to begin. As autumn turned to winter in 2025, 3i Atlas reached the closest point in its journey to the sun. Scientists call this moment perihelion. For a comet, it is the most important moment of its entire visit. This is when the heat from the sun is strongest, when the ice melts fastest, and when the object reveals the most about what it is truly made of. For 3i Atlas, this moment arrived on October 29th, 2025. During this time, The comet passed too close to the sun for ground telescopes to observe safely. For weeks, scientists lost their direct view. They could only wait patiently for the object to move back into a position where instruments could study it again. When 3I Atlas finally reappeared in December 2025, moving away from the sun now, astronomers rushed to point their telescopes at it one more time. This was their best remaining chance. The object was already speeding up, pulled along its long, curved path, heading back toward deep space. The James Webb Space Telescope was given priority time to study the comet during this critical window. Using powerful instruments capable of reading fine chemical detail, scientists captured new spectra, essentially a detailed fingerprint of the light, coming from 3I Atlas's glowing coma. What they found confirmed much of what earlier data had suggested. The comet's chemistry remained extremely unusual, unlike any other comet ever studied. The high deuterium levels stayed just as extreme as before, complex organic molecules were still present, and the mysterious pulsing gas jets, the pattern that had caused so much debate, continued in similar rhythm as the object moved away from the sun. But this new, more detailed data gave scientists something they had needed all along. A much clearer picture of the comet's nucleus, the solid, rocky, icy core hidden deep within all that surrounding gas and dust. Using measurements from multiple telescopes together, including Hubble and Webb, researchers finally estimated the size and shape of the nucleus with much greater confidence. It was found to be small, likely somewhere between half a kilometer and a few kilometers across, an ordinary size for a comet nucleus. More importantly, detailed models of its surface showed something that finally offered a strong natural explanation for the strange gas pulses. The nucleus appeared to have a surface made of different materials in different areas, some icier, some rockier, arranged unevenly across its shape. Combined with a slow, complex rotation, this uneven surface could easily create pulses of gas that did not match a simple, steady pattern, exactly the kind of irregular rhythm scientists had been puzzling over for months. This explanation did not rely on anything artificial. It did not require life. It simply required an object more complex and unevenly formed than most comets studied before, something entirely possible for an object that likely formed under extreme ancient conditions billions of years ago in a completely different part of the galaxy than our own solar system. For the majority of scientists, this was the answer they had been waiting for. Careful, natural, and grounded firmly in real data. Papers were published. Peer-reviewed studies confirmed the findings. Slowly, the wilder theories that had spread across social media began to quiet down, replaced by a calmer, evidence-based understanding. 3I Atlas, scientists now agreed, was almost certainly the oldest comet ever studied by humans, likely between 10 and 12 billion years old. It probably formed in a cold, distant region of the early Milky Way galaxy, long before our own sun existed. Its unusual chemistry told a story stretching back nearly to the beginning of the galaxy itself. Its complex, uneven surface, shaped by billions of years drifting through the emptiness of interstellar space, explained the strange behavior that had captured the world's attention. No hidden structure, no artificial signal, no confirmed sign of life. Just an ancient, remarkable visitor from a time before Earth even existed, passing briefly through our neighborhood before continuing its long journey back into darkness. And yet, even with this careful, scientific conclusion, a few smaller questions remained technically unanswered. A handful of researchers pointed out that some of the finer details in the gas pulse timing still did not perfectly match even the most advanced surface models. The differences were small, easy to overlook, and well within what many scientists considered normal scientific uncertainty. But they were there, quietly noted in a few technical papers, never fully resolved before the object moved too far away to study in this kind of detail ever again. By early 2026, 3I Atlas had moved beyond the reach of most instruments capable of capturing this level of detail. It continued speeding along its long, curved path, gradually leaving the solar system behind for good. Unlike a normal comet, bound by gravity to circle the sun again and again, 3. Atlas was simply passing through on a journey that had already lasted billions of years and would now continue for billions more, heading back out into the vast emptiness between the stars. For scientists, the story became something to reflect on carefully. In many ways, it captured everything remarkable about modern astronomy. In just a few short months, humanity had detected an ancient traveler from another part of the galaxy, studied its chemistry in incredible detail, debated its strange behavior with genuine scientific rigor, and ultimately arrived at a careful, well-supported, natural explanation, all while a much louder, less careful version of the story spread across the internet at the same time. It also served as a reminder of something important. Space is full of objects far older and far stranger than anything found on Earth. As telescopes continue improving, and as scientists gain more experience studying rare visitors like 3I Atlas, more discoveries like this one are almost certain to come. Perhaps the next interstellar object will behave in an even more surprising way. Perhaps, one day, real evidence of something truly unexpected will finally be found. But for now, 3I Atlas keeps its final secrets close, carried quietly along its ancient path, farther and farther from the sun with each passing day. Somewhere out there, in the vast darkness between the stars, another interstellar traveler may already be on its way, unnoticed for now, waiting to be discovered by the next generation of telescopes watching the sky. And when that day comes, scientists will be ready, cameras pointed upward, waiting once again to ask the same question that 3I Atlas first brought to the world. What exactly is out there, and what more can it teach us about the universe we call home? For now, the mystery of 3I Atlas remains mostly solved but not entirely closed. And perhaps that small gap between fully understood and completely explained is exactly what makes stories like this one so difficult to look away from.